This problem is called remove duplicates from a sorted list. We are given a head of a sorted linked list. We have to delete all duplicates such that each element appear only once. And we have to return the linked list sorted as well. So the first hint here is that we have a sorted linked list. Remember, if we have a sorted array, sorted linked list, sorted anything, the adjacent element, if there are duplicates, will be the same. So in this case, for example, we have 1, 1, 2. The list is sorted, and we know that if there's a duplicate, if there's a node that if there are multiple nodes with the value 1, they will be appearing adjacent to each other. So in this case, 1 is appearing next to 1, and we have to remove one of those. So the result of the list will be only nodes, basically distinct nodes, in this case 1 and 2. So for the second example, again, we have 2 1s, so we have to remove one of them, and then we have 2 3s, so we have to remove one of them, and we have to return 1 2 3. So basically sorted linked list without duplicates. The number of nodes in the list is in the range 0 to 300. The node values are from -100 to 100, and the list is guaranteed to be sorted in descending order. We have to reuse somehow this property that we are given a sorted linked list. So basically, if it wasn't sorted, then we would have to track the duplicates via the hash map or a hash set and remove them using the previous node, so reconnecting the next relation from the previous node to skip the duplicate element. But in this case, because we have adjacent elements that are the same, if they have duplicates, they will be adjacent. We can reuse the algorithm that we have already created before, the algorithm from the problem remove linked list elements. In that algorithm, basically, we are checking in the future if the element has the value equal to val. This can be generalized. It doesn't have to be a specific value. Basically, for each of the elements, so let's say our current is pointing to the element 1, to the node 1. If you look in the future and we have a node that has the same value as our current node, we know that we can skip it, because at the end we want to keep only one of these nodes with the value 1. So at the end, like, we will remove all the duplicates except for the one, because at the end that element will be distinct. So in this case, to remove this element, just say we have 1, 1, and 2. To remove the second element, we will just relink the next relation to point to the next element. And we will keep on doing this as long as we don't have two different nodes. And when I say two different nodes, that basically means that the value of the node that you are currently pointing to has to be different than the value of the node that's next to this current node. So in this case, we will have 2 1s, and we will basically remove them, and we will move our current we'll move our next relation always to the next element. So in this case, now current will be pointing to a node with the value 1, and the next will be pointing to a node with value 2. 1 is not equal to 2, so we know that we don't have any more node values with the number 1. We only have 1 because we removed all the others. So we can go to the next element in the list, which is basically the element 2. And then for the element 2, we will be checking if we have any duplicates and so on until we reach the end of the list. Now for the time complexity, because we are only traversing the list, we will have linear time complexity. And for the space complexity, we are not creating any hash map or hash set for the set for the duplicates, because the list is already sorted and the adjacent element will be could possibly be the duplicate, so we will have constant space complexity. First, we'll check if we have an empty list. If you have an empty list, there's nothing there are no duplicates because there are no elements, so we just return another empty list. Next, we'll create our dummy that will be pointing to the head, and we'll set our current to be pointing to the first element, to the head element. Next, we will iterate as long as the current is not equal to null, so as long as we are pointing to a valid node in the linked list. And for each node, we will be checking if the next node has the same value. As you can notice here, the current is not pointing to the same artificial dummy node. It's pointing to the head. It's pointing to the next node. Why is that? Because we have to compare the next node with something. In the remove linked list elements problem, we were comparing the value of the node with the val input parameter. So the dummy element could have started. The current could have started as to point to the dummy node. In this case, we have to start from the head element because we will not be removing the head element. Let's say the smallest element that we have in the linked list is the element 1. We will keep the head of that linked list with the node value 1, even if we have duplicates, because that element is the first element that has the value 1. If you remove all the other second, third, and fourth, the final list will still contain distinct elements. It will contain the first and the only node with the value 1. So we are good on that. So basically, we will be checking in the future. We will first checking if the current next is valid. So if we have a valid next element, and if we do, we will check if the value of the current node is equal to the value of the next node. If it is, we know that we have to skip the next element. So we will just redirect our next relation to point to the element after our next. That's why we are using the two next statements. Don't be confused with the two while loops. That doesn't mean that we have a quadratic time complexity. At worst, we will iterate over all the elements in the linked list once, and we will have linear time complexity. Once we have found an element that's different, it has a different value than our current node, we can just move to that next node, and we will repeat this process as long as we have valid nodes, as long as we are pointing to a valid node in the linked list. Finally, we just return the dummy next, which just basically represents the head of our sorted distinct linked list.